So I want to do one more example for initial value problem. So here I have y double prime plus y is equal to 1. The initial conditions, y of 0 is equal to 2, and y prime of 0 is equal to 3. So this is a second order because it's double prime, and this is non-homogeneous because it's equal to 1 instead of equaling to 0. But I'm still doing the same thing, Laplace each term. So the Laplace y double prime plus Laplace y, and then Laplace the 1. So starting with this, because it's second order, so we get x squared y of s minus s y0 minus y prime of 0. So all of that is just from the y double prime. Then when you Laplace y, we get y of s. And when I Laplace 1, I get 1 over s. So we're going to have to do the same thing. We're going to evaluate y naught of 2, y prime naught of 3 equals 3, and plug those in. So s squared y of s minus s y naught is equal to 2 minus y prime, which is equal to 3, plus y of s is equal to 1 over s. So I need to solve for my y of s, which I have here and here. So I'm going to move these terms over. So 1 over s, 1 over s plus 2s plus 3. These two terms have the y of s, so I'm going to factor that out. And I'm left with s squared plus 1. So divide that out. I get 1 over s times s squared plus 1 plus 2s over s squared plus 1 plus 3 over s squared plus 1. So those are my terms, and now I can take the inverse Laplace of each. Okay, so I have each of those terms listed out. We start with our inverse Laplace of y of s, which will just give me the y of t. Here I have a little bit of work to do. So I have 1 over s times s squared plus 1. Well, I need to break that up with partial fractions. This one is fine. I can just factor a 2 out of the top, and then I'm of the form s over s squared plus k squared. And this one is fine. That's going to give me the form of s squared plus 1. S squared plus k squared on the bottom, sorry. And I can factor that 3 out. So I'm really just focusing on here first, and then we can go and pull the rest of that together. So I'll do it over on the side. Because there's that s squared plus 1, I'm going to need a linear factor on top. So that's going to be bs plus c. Multiply it through. 1 equals a times s squared plus 1 plus bs plus c times s. So I'm going to multiply this out. We get as squared plus a plus bs squared plus cs. Well, I can tell from here that a is the only constant there, so a has to equal 1. There is no s term over here, so c has to equal 0. And a plus b has to equal 0 because again there's no s squared term over here. So b is equal opposite of a. So b is equal to a -1. C is equal to 0 and a is equal to 1. So I can split these up. And a was 1, so I get inverse Laplace of 1 over s plus the inverse Laplace of b was 0. So we get -s over s squared plus 1 plus inverse Laplace of 2s over s squared plus 1 plus the inverse Laplace of 3 over s squared plus 1. These two terms are like terms. I can put them together and that will just give me an s over s squared plus 1. So when I start to do the inverse, my y of t, the inverse Laplace of 1 over s is just 1. These two put together would just be s over s squared plus 1. So that's going to give me sine of t, because my k value is just 1. And this, I can pull that 3 out. So it'd be 3 over 1 over s squared plus 1. Again, my k is equal to 1. So this is cosine t. So that's what my y of t is.